Hi everyone, I am Dr. Subbarao from RVIT Institute of Technology. In this video, I am going to explain laser ablation method for the synthesis of carbon nanotubes. This is the schematic diagram of laser ablation method. It consists of mainly furnaces. These are the furnaces having the 1200 degrees centigrade temperature, and here a graphite target is placed in between the inside the chamber, that and here this is the laser, high intensity laser beam which is incident on the graphite target, and this one is the gas inlet and gas outlet which is used for the passage of an inert gas through the chamber. And here this is the collector. This is connected to the coolant. That means a cool water is circulated, or maybe it will be condensed. And this one is having the low temperature. So the collector is usually, generally we are using the metals. And this is the diagrammatic representation. If we placed a graphite target in the chamber and a high intensity laser beam is incident on the graphite target, then the particles from the graphite target ejected from the surface, and those are having the high temperatures, and they will condensed and deposited on the surface of the collector. So this is the deposited particles having are the nanoparticles. So this is the general procedure for the laser ablation method. And coming to the major key points, this process was developed by Dr. Richard Smalley at Rice University in 1955. And in this laser ablation, a graphite target is placed in a reaction chamber. So the graphite target is placed in a reaction chamber, and an inert gas like helium argon is sent into the chamber. So this is the gas inlet for the passage of the inert gas like helium, argon, or nitrogen gas. Next, a pulsed laser evaporates the graphite target at a 1200 degrees centigrade temperature in the chamber. So by passing the high intensity laser beam, this is incident on the graphite target. Here the furnaces are used for the maintain temperatures. So these are maintained up to 1200 degrees centigrade temperature. At high temperatures, the atoms present on the graphite target will ejected from the lattice. That means whenever the laser, high intensity laser beam incident on the graphite target, the particles exist in the graphite target will be ejected from the crystal lattice, and they will be having the high temperature, and they will deposit on the collector. So a water cooled copper surface may be used to collect the vaporized carbon nanotubes by condensation process. So after the vaporized particles will be condensed, and they will deposit on the surface of the collector. And by using this method, we can synthesize it up to 70% yield of carbon nanotubes. And it produces mainly single-walled carbon nanotubes with controlled diameters. We cannot manufacture the single-walled carbon nanotubes having the same diameter. That means entire carbon nanotubes have the same diameter. That is the controlled diameter. So this is about the laser ablation method. Here this one is the more expensive method when compared to the arc discharge method and chemical vapor deposition method. Why? Because here we are using the high temperature maintained furnaces and high intensity laser beam. So this one is the maintenance cost is also very high. So this is the diagrammatic representation and the theoretical explanation about the laser ablation method. So here this is the animation I am showing here how it will happen. So this is the laser beam, high intensity laser beam, and this one is the target material. and this one is the collector. So there are mainly laser, target and the collector. This is the video I'm showing. This is the deposition of the carbon nanotubes on the surface of the catalyst or metal. So the high intensity of laser beam coming from the laser, which will incident on the surface of the target, and the particles ejected from the graphite targets and they will deposit on the collector. This is the high intensity of laser beam hit the target and the particles are ejected from the target and deposit on the collector. This is the deposition of the particles ejected from the target. And this hole is conducted in a high vacuum chamber. This one is the high vacuum chamber, and here thermometer is there which will controls the temperature inside the chamber. And by using this technique we can synthesize various samples. That means different types of carbon nanotubes will be synthesized by using this technique. Thanks for watching. If you like this video, please like, share and subscribe. Please click the bell icon symbol for more informative videos. Thank you.